Hello, my name is Ethan Volante, and I'm going to be talking about my gathering ants and their finite state machines. So the whole premise of this research project is I wanted to create an AI that acts like ants, gathering food through the use of finite state machines and influence maps. Now these ants, they can roam in random directions. These random directions are determined by waypoints, and they can find and pick up food, which is both placed already in the scene and can be placed by the player. In addition, once they find food, they place pheromones on their way back to the colony, and once they're done, they can follow the pheromones that they just placed, or other ants can follow these pheromones placed by this first ant. Starting with roaming, it is all based on waypoints, which have been placed all around the map. These waypoints are held within a list, and what it does is it goes through the list and finds a random waypoint, then determines which direction the ant should go. And the ant will continue to go along that path until it reaches it, or it is interrupted either by food or by a pheromone. Next is finding food. Once they've found food, and this is only whenever the ant has gotten within its detection range of the food, the ant goes over, grabs up to 3 food, and then delivers this food to the colony. Now, the food itself holds up to 5 food. Once it has been used up, then it will disappear. Once the ant has grabbed the food, it'll start placing pheromones. And what it will do is any waypoints within range of the ant will reset its pheromone value based on the distance between the waypoint and the food itself. The further away from the food, the higher the value. Then, after a certain amount of time, the pheromone will start to fade. And in addition to the base value already being higher based off of distance, the speed in which it fades will be faster based off of how far it is from the food. Once the pheromones are placed, ants will begin to follow these pheromones only once they get within range of the pheromone. And it'll start by following the strongest pheromone. It'll move between these strongest pheromones as it goes through a list and finds the strongest one within range. And it'll keep doing that until it can't find the stronger one, in which it will then begin to go between 2 different waypoints that have the strongest pheromone back and forth until eventually the pheromone disappears. And the ant can also be interrupted once it finds food at the end of the pheromone trail. So this is where the influence map part comes into, is because all of these waypoints in which there are pheromones placed on them have a certain value attached to them, and the ants will follow whatever is the strongest pheromone. In this case, the lower the number, the stronger the pheromone is. So it becomes less and less expensive to move to the next waypoint. So this is my logic behind the finite state machine itself. With it starting at roam, it will keep roaming around until either it finds a pheromone to follow or a food to gather. Once it reaches the follow, it'll continue following until it finds a food to gather, or if the pheromones run out, then it'll go from follow back to roam. And then with gather, it'll gather the food and immediately go into the deposit, in which it'll just be from the food itself to the colony, a straight shot. And once it drops off the food into the colony, and it'll immediately start roaming again, in which case it'll immediately start following because there will more than likely be pheromones placed by the ant already. Okay, so now I'm going to show the demo itself. Okay, so as you can see, all of the ants are the little red dots, and then the food itself are these little candy corn looking things, the colony being the black gem, and then the pheromones themselves are the little blue dots once an ant finds it. And starting with the ants, as you can see, the ants will roam in a random direction across these random waypoints that cover this entire screen. Um, and so once they get close enough to a food, they will immediately start like gravitating towards it. They'll go into a gather and then immediately starting to deposit. And once they start gathering, they drop these pheromones, as you saw just there. And they'll, if they're depositing, they'll ignore these pheromones until they drop them off, and then you'll see other ants, including the ant himself, go and follow those pheromones. And you can see the case in which the ants end up going in a sort of circle here. In addition, as you've seen quite a few times, is once the pheromones are placed down, a certain amount of time will pass, which is represented right here, before they start to fade, which this one should be fading right here. You see how it starts at the colony and then slowly begins to fade when it gets closer and closer to where the food originally was, and then it'll completely disappear, releasing all of these ants. Now, how these waypoints work exactly is they are, as I've said before, they are a bunch of waypoints that are placed across the entire screen, with it being only one grid space between each other, which you can actually see is that's the distance between each waypoint. So that means the total amount of waypoints in this map right here is 252 waypoints. Okay. On to some of these fancy little buttons here. Starting over here, you have the current amount of ants you have right now, which is 14 ants. And I can spawn an ant whenever I press S. And right there I just spawned one, which you can see is now 15 ants, and I can just spawn as many as I would like, and they immediately start doing their job of running around and looking for food right there. Um, and yeah, like you've seen me use it a few times now, is spawning food, which is just left click, and it just spawns exactly wherever my mouse is. Um, and yeah, next is this bottom right, which is the pheromone duration. Now, this duration is in terms of seconds. Based off of what this number is how much time it takes for the pheromone to start fading. Which I can increase it if I press I. You see now it's 6 or 7 or 8. Or I can decrease it under. I can't go below 0 because you can't have a shorter duration than 0. But what's interesting is that I can start out as 5 and then just put a food right there, and I can increase it a bunch, and it will now stay there for 19 seconds, even though the pheromones were placed down when it was just 5 seconds. So it adapts to however much you would like it to be. So let's just put that back down to 5, and then they should start fading pretty soon. Right there. Yeah, there we go. Okay. Yeah. And then up here we have like level selection, something basic of a level selection, where I can choose to go to the next level, the previous level, or restart this current level. So right now I'm going to restart this level. So now you see it's back to its original position. And if I try to click previous level, with this being the first level, I can't do anything. Nothing happens. I'm clicking it right now, nothing's happening. Yeah, and so something that I would like to test right now is something of a stress test, which is just spawning ants constantly until the demo itself starts to lag. Now, this does take a while if all of the ants are just roaming. As you can see, it's starting to get a little laggy at 156 ants, but it really starts to lag if I place down the food and there's a bunch of ants in one group going between just 2 different waypoints, those being the strongest pheromones, and you can see it's starting to get a little jittery here. And then after few seconds, it'll all dissipate and they'll release, and then it'll be back to normal. Now, I found through testing the test, or I have found through testing that the limit is around like 300 for this map. So I'm just going to get to that point real quick. So at 316, it's getting a little slow, but this should be fine up until about 400 is where it really starts to show. Yeah, you can see here it's starting to lag quite a bit. So I'm just going to restart the level, have back to down to 14 ants, and then move on to the next level, which this next level is a sort of copy of the previous level with 14 ants and the food being in the same place as before, but now the duration is 10 seconds. As I found with a larger map, it's a better amount of time for the food that spawns really far away, or the food that I place that's really far away. So now there's a lot more waypoints out of this entire screen, and I can place food all the way over here, and then an ant will find it and lead it all the way back to the colony again. No matter how far away it is, the ant will always go back to the colony. And so the difference in waypoint for this map is still one grid in between, same size, everything's still the same, except for the grid amount. The amount being 2,079 waypoints. So the same as last level, you have 14 ants, and you can spawn in as many as you would like. And they do still have their little states attached to them, but they're basically impossible to see. It was more meant for the first level to be able to see. And then you can spawn food still and everything like that. Increase the duration, decrease the duration, and then I can restart the level if I would like. And if I tried to press next level, nothing will happen because there is no next level. I can go back to the previous level. But right now, we're going to focus on this one because I would like to do the same test as before, which was the strain test. And so there is actually a really big difference between these two levels because there are a lot more waypoints, which means there's a lot more processing that the ants have to go through. So I'm just going to start spawning them, and it should already start to lag when we get into 60, and it's already, you can see the ants jittering a little bit. And I'll bring it up to 100, and you can see some of the ants like jittering at their waypoints that they went to, and you can see them lagging around. And these are, compared to the previous level with being able to put 400, just 100 is a lot. It's a huge difference. So there we go. Okay, so in conclusion, my waypoints is a simple but very expensive method. Once you get into the thousands of waypoints, it can start to get very laggy. And I would prefer to use a grid method, which I have seen a few things online in which you can make a grid, attach values to them, and then do pretty much the exact same thing that I just did here. But the grid method I have found to be quite a bit more complicated. So some other places in which you can apply this kind of method is you can use it for different bugs or animals that have simple behaviors of running around and following each other. One example would be like wolves as a very specific one because they typically travel in packs, so you can set up something relatively simple with wolves just following each other around a certain area and avoiding other wolves. In addition, you can actually set up a sort of more complex AI with humans and nature trails. With nature trails, you tend to see a lot of people like to go off of the trail and then follow their own path, and then once one person sees that path has been walked upon, then that next person will follow them. So it could be used for something sort of like level design. And just anything that regards following behavior, you can apply this to. So yeah, thank you for listening to my presentation on gathering ants and finite state machines.